welcome back to my channel. We have this equation here. Solve the first order equation. Okay. We have the equation again. X dy with the x plus 2y equal to 8x squared. Now we're going to rearrange this equation in the form of dy by the x equal to, alright? So let's have x dy over the x is equal to 8x squared plus 2y crossing the x minus 2y, and then y we need to rearrange the equation so that we know the appropriate method we are going to use for the solution. Okay? So now we have dy over the x is equal to 8x squared minus 2y over x. Then if you watch closely, you find out that we can be able to solve this equation by variable separation. Alright, and we can't use homogeneous differential equation. We cannot use substitution y equal to vx because this is degree 2, this is degree 1, and this is degree 1. So the degree are not all the same. So let's try out the method of exact differential equation. Therefore, we're still going to what? Express this in form of exact differential equation before we can go ahead. Alright, so we cross multiply, we find out we have 8x squared minus 2y, or the x will be equal to x multiplied by that x to y, so that we have 8x squared minus 2y all the x. This crossing to this side is minus x. The y is equal to 0. Okay? So now we have this equation in this form. So this side is the m and this side is n. So comparing this with the general form of exact differential equation, m dx plus n dy is equal to 0, then it's evident that m is actually equal to 8x squared minus 2y, and n is actually equal to minus x. Okay? So the partial differentiation of m with respect to y, the partial differentiation of m with respect to y is equal to, this is the constant, so differentiating minus 2y is minus 2 with respect to y. Then the partial differentiation of n with respect to x, of course, this will give us minus 1. Then if you watch, you find out that the equations are not the same. So this means that the partial differentiation of m with respect to y is not equal to the partial differentiation of n with respect to x. Then this is not, and of course it's not exact. So we're going to find the integrating factor, finding the integrating factor mu. Okay, such that f of x is equal to partial differentiation of m with respect to y minus partial differentiation of n with respect to x all over n, of course, is equal to f of x. So what's a partial differentiation of m with respect to y? Of course, we'll trace it here. It's minus 2. We have that's equal to minus 2 minus the partial differentiation of n with respect to x minus 1. We have minus 1 all over n, and of course n is minus x with minus x. So negative 2 negative is positive. So that I have minus 2 plus 1 over x. Minus x definitely gives us minus 1 over minus x, and we have 1 over x. So f of x is actually equal to 1 over x, so we can find our integrating factor. So we have So our integrating factor mu is equal to exponential integral over f of x dx, which is equal to exponential integral of 1 over x dx, which actually will give us exponential in x, and that is equal to x. That's when you take the natural logarithm log of x to the base of e, you find out the x becomes the answer you're going to have there, so that our integrating factor is equal to x. Then using x, which is the integrating factor, to multiply the equation here, which is the equation we are using for the exact solution. So we have x multiplied by 8x squared minus 2y dx. That's we're now multiplying this equation with the integrating factor to make it exact. X multiplied by x dy equal to 0. So we have x multiplied by that to give us 8x cubed minus 2xy minus x dot x is x squared dy equal to 0. Okay, let's check if, we have dx minus x squared dy equal to 0. So let's check if the equation is now exact. M is equal to 8x cubed minus 2xy, and n is equal to minus x squared. Okay, so we're going to differentiate partial with respect to x here, with respect to x, with respect to y here. This is x variable, we're differentiating with respect to y, so this is constant. We have minus 2x with respect to y, and partial differentiation of n with respect to x here. Definitely differentiating minus x squared definitely will give us minus 2x. As you can see, the partial differentiation of m with respect to x is now equal to, respect to y, is now equal to partial differentiation of n with respect to x is exact. It's now exact. So we can now continue the solution. Okay? We can now continue the solution. Alright. There exists a function z over x comma y such that partial differentiation of z with respect to x is equal to m. Okay? Is equal to m. So that we have integrating both sides to give us the function z of x comma y. Of course, when you integrate a differential function, it will give you a normal function z. So integrating partial derivative of z will give us normal z, which is equal to integral of m. That's integrating both sides. Integral of this will give me z. Integral of m with respect to x. Of course, integration goes with a constant c of y, because we keep x constant here, we keep y constant because we're differentiating with respect to x. Therefore, the function then will be with respect to y. Okay. So we have z is equal to integral of m. Of course, our m here is 8x cubed minus 2xy. Okay, with respect to x plus c of y. Okay? Z is equal to, integrating with respect to x here is 8x raised to the power 4 over 4 minus with respect to x is 2x raised to the power 2y all over 2 plus c of y. Okay, so I have to reduce this to 2 and cancel out this so that z is equal to, of course, 2x raised to the power 4 minus x squared y plus c of y. Okay, this is our main function. We're going to figure out what c of y is, and then how do we do that? We use the second condition. There exists a function differentiating this function here, z with respect to x with y is with respect to y is equal to n. Second function, right? So the partial differentiation with respect to y, the partial differentiation of z, and of course the z function is 2x or 4 minus x squared y plus c of y is equal to n, and of course n is equal to minus x squared. So differentiating this guy with respect to y, there is no y here, is constant. This function is considered a constant, and then differentiating y here is 1. We have minus x squared plus c of y equal to minus x squared. So this is c prime of y, and of course that's the differentiation of c of y because it's acting as a function of y. And cancel x squared from both sides, we have 0 here. C prime of y is equal to 0. To find c of y, we integrate both sides, and when that happens, actually we're going to have c of y equal to k. That's the integral of 0 is a constant, the differential of constant is equal to 0. Then we can substitute the value of c of y to our measured equation. Therefore, since you know what the constant is, we can now say z is equal to 2x raised to the power 4 minus x squared y plus c of y, and c of y is equal to k, so plus k. We'll take k to this side, we have z minus k is equal to 2x raised to the power 4 minus x squared y. Of course, we have a is equal to 2x raised to the power 4 minus x squared y. Okay, where a is equal to z minus k. Thank you and have a wonderful day. God bless.